Hi guys, today we're going to discuss FPM, Further Pure Math, Paper 2 from EDEXCEL IGCSE past paper. So this is number 10, figure 1, and here shows that curve M with equation y equals to x cubed minus 13x minus 12. The point P with x coordinate -2 lies on M, and L1 is the tangent to M at point P. Question 1a, 10a. Find an equation for L1. Find an equation for L1. So how could you do that? So you may pause this video and take your time to solve this. So here's the discussion. So we have here is a tangent L1. We can count this by taking the first derivative of the original equation, that is a y equals to x cubed minus 13x minus 12. So we take the first derivative, so x cubed becomes 3x squared, minus 13x becomes minus 13, and -12 is 0. That is the gradient function of the tangent, while when x is equals to -2, so we substitute x with -2, we will get 3 times -2 squared minus 13, that is 3 times -2 squared is 4, minus 13, that is 12, minus 13 is -1. That is the gradient of the tangent line at point P. And find the equation. So we have to get the coordinate of point P for x -2. Plug the -2 into the original equation here. So -2 cubed and then minus 13 times -2 minus 13 times -2 minus 12. So if we count this with calculator, we will get 6. So the coordinate is -2 and 6 for point P, somewhere here. And then equation line is y equals to mx plus c. Well, we can plug the y is 6, the gradient is -1, and then x is -2 plus c. Now we find c. 6 is -1 times -2 is 2 plus c is 4. So this is our equation of line 1, y equals to -x plus 4. Next. So now we have a question B. The point Q lies on M, and line L2 is the tangent to M at point Q. So given that L1 and L2 are parallel, find an equation for L2. So this is the original equation, original question here. 10b. This is the continuation from 10a. So it's up to here. L1 and L2 parallel, that's what we know. Find the equation for L2. So this is how it works. So L2, it has the same gradient with the L1. So since L1 we got from the top is -1, so the gradient of L2 should be -1 as well. Now what is the point Q? We have to find out the xy coordinate of point Q. So to get the gradient, of course, we have to take the first derivative again. This is our first derivative, and we plug into -1 because gradient of tangent at point Q is -1. Then we find the x, the value of x. So we move this one and then rearrange the equation. This would set is 0, so we move the -1 to the right, become +1. -13 +1 is -12. Then we factorize the 3, so 3 become a factor, and then what is left is x squared, and then -12. Take 3 out is -4. So now we can factorize this one as difference of square. X squared minus 4 is x squared minus 2 squared, that is x plus 2, x minus 2. So we get the equation. The value of x is -2, or if x minus 2 equals 0 is x equals to 2. So from the previous question, line L1 has the coordinate of -2. Of course, now line L2 has the coordinate of x, or coordinate of 2. Now we plug the 2 into the original equation of the curve. So this is the curve M. We plug the 2 into x, so 2 cubed minus 13 times 2 minus 12 is negative 30. So the coordinate of point Q is 2 comma negative 30. Now based on that, we take the line equation as y equals to mx plus c. Now our y is negative 30 and our x is 2. So now the gradient is the same, that is negative 1, like at the top here, negative 1. So m is negative 1 times x is negative x plus c. So the y is negative 30 and the x is 2. So we plug the 2 into x. So now we have negative 30 equals to negative 2 plus c. So c equals to negative 28. So this is our line equation. Y equals to negative x with the c is negative 28. That is the L2. Now next we have question C. Question C, it says that the normal 2m at P, somewhere here, meets L2 at point R. Find the coordinates R. So to count this, we need to sketch a little bit to make it clear where is the coordinate of R. So let's sketch here. We have a L1 here, we have L2 here. L1 is at point P with the coordinate negative 2, 6, and L2 is point Q with the coordinate 2, negative 30, and they are parallel. Now the normal 2m at P here, so we draw a normal line to this red line, so this is yellow line, represent the yellow line. It cuts the L2, which is blue, at point R. Okay, so now what is the coordinate of point R? So of course we have to know the line equation of the tangent of L1. So the tangent has the gradient of negative reciprocal. If this is negative 1, so the gradient for the tangent must be positive 1, and it passes through the same coordinate, negative 2, 6. We make the line equation. So normal at P will be m equals to 1, and then with the coordinate negative 2, 6, we plug in y minus y1 equals to mx minus x1. So y minus 6 equals to, gradient is 1, x minus x1 is, in here, negative 2, x minus 2 is x plus 2. Rearrange the equation. Y equals to, this become 1 times x is x, 1 times 2 is 2. Move 6, negative 6 to the right, become positive. So y equals to x plus 8. That is the normal line at P. So now how do we find the point of intersection with this L2? So we have to equate them. Y equals to negative x, negative 28 here, and then equals to, the normal equation is x plus 8 at P. Now we equate them and group the number with number, x with x. Now negative x from the left to the right become positive, 8 from the right to the left become negative. So this will become negative 36. X plus x is 2x. Now x equals to negative 36 over 2, that is negative 18. So the coordinate will be negative 18. And how to get the y part? We just plug in into one of this equation, either L2 or the normal line equation. So now we have plugged negative 18 to here, so we'll get negative 18 plus 10 plus 8, that is negative 10. So guys, so this is the sketch of the graph. This is the curve M, and this is the L1, and this is a normal at P. L1, this is point P, this is point Q, this is L2. So this is the intersection of L2 with the normal at point P, that is negative 18, negative 8. Okay, I mean negative 18, negative 10, negative 18, negative 10. So here we go. This is our point, P here, Q here, and R here. Now let's move on. Okay guys, now question D, find the exact length of line PR. So for this we just have to use the formula for the length of between 2 points, that is PR equals to square root of x1 minus x2 square plus y1 minus y2 square. So coordinate of P is -2, and then coordinate of Q is minus 18, and then the y coordinate is 6 minus the y coordinate of R is minus 10. So we just have to count and rearrange the equation. So this will become plus 16 square plus 16 square. So now it will become a square root of 2 times 16 square, and then we can actually take the square root of 2 out, and square root and square cancel out, so 16, so it will be equal to 16 root 2. Okay, now we are in question E, the tangent and normal at P and tangent and normal at Q. So P and Q, this is P and this is Q, form a rectangle. This is as shown. So find the exact area of this rectangle. So we got the equation for the normal at point Q with the same line equation. So then we have to know the length of RQ. So we already know that the length of PR is 16 root 2, that is PR. So of course for area of rectangle we need to know the length times breadth. This is PR, is already found, so we have to know the length of RQ. So let's count the length of RQ. So the length of RQ, same with the line equation. RQ is the root of x1 minus x2 square plus y1 minus y2 square. So now we have a minus 18, and then here will be minus 2, and the y part is negative 10, and then minus 30. So it becomes positive. Then we rearrange and simplify this, so we'll get negative 20 square plus 20 square. So it's the same as root of 2 times 20 square, because negative of the square is also positive. Now we can take out the root 2, and then square and square root is cancel out, so 20. So we get 20 root 2. So now we know that this is 20 root 2, and this is from the top is 16 root 2. So then we can find the exact area of the rectangle, that is length times breadth. So area will be 16 root 2 multiplied by 20 root 2. So then we will get 320, that is from 16 times 20, and root 2 multiplied by root 2 becomes 2, so we get 640 square unit. 640 square unit. Okay, that is the answer. Alright guys, that's the answer for the last E. So we have covered all this question. From A to E. Okay, so if you have any challenging question, you can write down in the comment section and upload the question in Google Drive and send the link in the comment sections, and we will reply to you. And so today's discussion is conducted by Study with Tuition Online. We cater for all these program and syllabus. Email us if you're interested to join with our online tuition. Don't forget to subscribe and ring the bell so you get notified when we release our latest updates, so you won't left behind. And check link in the description. There are many free sources from grade 3 to grade 12 and also pre-calculus and for college. Bye bye and see you in the next video. We hope today's discussion will be helpful to you, and God bless you.